Okay, I think I am live. You all can be the judge of that. Let me know if I am live. Just throw something in the chat. Let me know you can hear my voice, and we'll all be off to the races. Miss Raquel, good morning. Good morning. What a fine morning it is. Secret stream? Is it secret? I don't know if this is a secret stream. But, Banana Jewel, I did miss your very random beginning comments in my live stream. I missed it all summer long, so I'm happy they're back. Secret stream. I like that. Maybe this whole time you've been passing me like weird like messages or something. And if I should have been like keeping track of them and like piecing together, it was like a big like code that I was supposed to decipher. I'm just gonna tell myself that's what's been happening. It was like something really important there, but I've just completely missed it. David, good morning. Good morning. All right. Well, we're all here in the online place that we meet. Thank you for being here on our second live stream for the week. Again, I know I mentioned this last time, but I just want to make this crystal clear for anybody who's watching this who maybe didn't watch the first one or something. So the normal schedule is that we'll only meet on Thursdays for a live stream every week. This week was just weird. We did a Tuesday live stream and we're doing a Thursday live stream, but that's because the first stuff we do in the class is kind of just like get your environment set up, read the syllabus, you know, do a few little housekeeping things, and I don't want to give you like a whole week for that because a lot of that just eats up time near the end of the semester where I'd like to give you more time for the stuff that usually people are struggling more with. Um, so I'm going to just take a quick gander at my notes while I'm doing that. If you have any questions about the humongously large amount of time I spent on the syllabus last time, throw it in the chat. Feel free to do that, and I'll try my best to address it. We also did a little coding last time. Just I guess as a heads up for my plan for today. So today I'm going to do more review. So last time when we actually got to the coding, I really just did a little bit of coding, and it was meant to just sort of introduce you to C++. I didn't introduce any new concepts. From my perspective, nothing that I introduced last time conceptually was new. It should have all been stuff that you've seen before. It's just that you may not have known how to do it in C++, so that was kind of the point of it. Today is going to basically be the same. I'm not going to introduce any new concepts in the sense that my expectation is that every concept I'm about to talk about today is something that you should have covered in your CSCI 20 or equivalent class. I get that that might not be true for everybody, which is why I do this. But the main thing that I'm hoping you'll get out of today will be seeing those concepts in the in the language of C++, and that way you can kind of connect the dots and understand also that the things that you learn in your first class, they carry over, and most languages are like that, especially the imperative languages. If you know C++, you know C# pretty well. You already know Java all right. You already know Python. There's like a whole bunch of languages that you can step into. The concepts will all be basically the same, and then you're just going to spend your time learning the syntax, which is what we're going to be doing more of today. I'm not seeing any questions, which is good. So yeah, let's just jump in, and off to the races we go. This is the program I wrote last time. So what I was going to do today was I'm just going to mess with this a whole bunch. And I'm going to do that in order to demonstrate some new concepts. So just to review, last time I kind of talked about variable declaration. I talked about cout and cin. So those are the two objects that you use in C++ to push information to the output buffer or retrieve information from the input buffer. I talked about initialization. Remember I was talking about how in C++ you better initialize your variables or bad things happen. We even talked a little bit about formatting the output for floating point values. That's a real specialty thing. You're probably rarely going to do this again in the class, but I don't know. Sometimes it's just fun to play. Um, do a little math. Hopefully that's nothing new. I showed you, and then also I think we finished things off with some conditionals. So hopefully, if else, that was nothing new or scary there. I think I kind of glazed over it, but commenting. So there's two kind of comments in C++. They're exactly the same as most other languages. So you can do what's called a block comment. Block comments are when you start with a forward slash and a star that starts a block comment, and then everything after that point will be commented out until you get to the first star forward slash. Everything in between will be commented out. That's called a block comment. It's what I traditionally use for my header blocks. The other kind of comment is a line comment, and that's just two forward slashes. Everything after the two forward slashes will also be commented out. Okay, it's exactly the same syntax as Go. It's actually the same exact syntax as C# and Java and a few other languages that I'm not thinking of. JavaScript's that way. Yeah, that's a really common convention. There's nothing hopefully scary there. So let's jump into new stuff. So what I'm going to do, what I figured I'd first start with doing here is turning this program, like right now, this is kind of like, I don't know, like the kind of program I would expect somebody to write if they were like in their first week or two of like learning how to program something, right? So they did, everything's in main. It's a very kind of just like, also it's a pretty simple program, so I mean everything being in main isn't that big of a deal. But everything's in main. It's not modularized at all. It's not, certainly not object oriented. So it's kind of like a little, like I'm just starting out sort of approach. So let's take it up a notch, right? So this, I'm going to rewrite it, and this time I'm going to rewrite it kind of like how I would expect somebody who is using like the C programming language to do it. So if you were writing in the C programming language, you would want to use functions. That's like their main vehicle for doing things. And so that's what I'm going to do. I'm going to introduce a function into this as a way for us to talk about functions and introduce how those work. So the way I'm going to do that is I'm going to write a function that basically does what this line of code was doing before, which is calculating the actual pay based on the hours worked and the pay rate. And this is obviously, the way I wrote it first time was really simplistic, right? This is like how you would calculate pay in like 1850. Like in the year 1850, like before we had overtime, before the, like, before we started treating our employees even mildly better. So I'm going to write I'm going to write a function that does it, but the function is going to be a little bit more sophisticated. It's actually going to take into account overtime pay. So if you work more than 40 hours in a week, you're actually entitled to overtime if you're an hourly employee. So that's what I'm going to do. So let's do it. I'm going to come up here to the top, and we're going to talk about functions. So I'm also going to get rid of some of this other stuff I had in here. You already have this. Hopefully you also, I think I talked about this last time, but if I didn't, that's my bad. I give you guys this code. So if you go, in fact, here, I'll briefly go back over there. Here's our our modules in Canvas. And if you come down here, every week it's going to be like this. So this is what we did last time. So here's the homework tip calculator. Here's the Piazza post. This is that quiz that I think I mentioned it last time. You can take this quiz as many times as you want. This is really just a review of how to use the command line. My expectation is that you all know how to do that already, but this is it. So this is a very typical layout that you would see. After the lecture was over, normally you would see this live stream recording show up in here. I didn't do this last time because if you did and you haven't done the course overview quiz, you wouldn't be able to get to it. So that's the only time I'm going to do that. For this next lecture, when I'm done with the recording today, you'll see it here. But also you'll notice when the lecture was over, lecture code showed up. So if you click on lecture code, this will always be where I put every time we have a lecture and I write code, which is most lectures, I'll put a copy of my code here so that you can always have access to it. Right? So you don't have to frantically write down every single thing I did. Like if you want to play or goof off with what I'm doing, then that's kind of why I do that. Okay. So here we go. I'm going to come over here and let's just start by writing sort of the template for how functions work in C++. So let's do it. I'll go with, oh, I don't know. We'll do a block comment here. That's the way to do it. And we'll do C++ non-member function definition template. Okay, that's a lot of words there. For those of you who've never had me before as a teacher, you might be looking at that and being like, I don't know what that means. What's a non-member function? What is that? So non-member function is just my way of saying a function that is not associated with a custom data type. It's not associated with a data type at all. Okay. So again, that's something I sort of expect you to know already at this point if you're in a second semester class. The idea of having custom data types and being able to associate RAM and functionality with them, something that you should know how to do at this point. If you don't have a strong background in that, don't worry, we're going to fix that today. But I am going to show you now how to do it in C++. I expect you to know how to do that, but maybe not how to do it in C++. So I'm about to write a function. It's a non-member function, which means it's not associated with a custom data type. Other words you might hear for this might be like in Go, this would have just been called a function. In the Go speak, they usually refer to their member functions as methods. Some other languages do that too. In C++, you would call it either like a non-member function or a free function. This is the reason why I do it. I kind of land on this naming convention, is because they're not really standard. Like, depending on the language, they might have a different word for it, and I think that's silly because they're all talking about basically the same thing. So for my classes, this is what you're always going to hear me talk about, is member and non-member things. Okay, and it's just my way of distinguishing between those two things. Watching coding lecture, sees coding, shocked. Shock, amazement, bewilderment. That's good. Okay, so if you took, I don't know, CSCI 4, you probably would use Python. You would have known that when you're writing a function in that, what do? They have a special keyword. They usually start with def in Python. If you took CSCI 20 with me or most of the teachers, you would have done it in Go, in which case you would know that the special keyword that they use for that is func. Well, C++ doesn't have a special keyword because they're better than all the other ones. No, they're actually, most languages copy what C++ does. It's an older language. Most languages actually just copy their notation, except for Python, because Python's interpreter doesn't even have return types. And then Go decided to just do their own thing. So most imperative programming languages, when you're defining a function, you actually start with the return type. Okay, so the return type is actually the very first thing that you would list when you're defining the function. After that, you would do the function name. Then you do an open and close parenthesis. And then inside the open and close parentheses is where you put the parameter list. Okay, so that's sort of how that works. Then you would have an open and close curly brace. The open and close curly brace in C++ denotes scope, just like it did in Go, and actually a whole bunch of other languages. If you don't know what scope is, it's another one of those things I sort of expect you to know how to do, but we will review it. And then inside of the scope of the function, you would have the body. I'll just put function body. Sure. There you go. So that's where like all the code would go. Okay, so this is the template that is sort of like all the little pieces and parts that you would need to define a non-member function in C++. Okay, notice how they're pretty much exactly the same that you would have seen in your previous CSCI 20 equivalent class. As long as it was a compiled language, it would have been this way. They always have return types, they always have a name, they always have a parameter list, and they always have a function body. Those four pieces are pretty much there no matter what language you're using. I've yet to see the language that doesn't do that. Those are just par for the course. They might change the order or where they show up, but that's just syntax. That's just how the language was designed. They all need that information. It's just how they stitch it together. Alright, this is the thing where you do functions outside of main to only return specific values instead of having everything loaded into your RAM while you're coding and executed, right? Oh, this is the thing where you do functions outside of main to only return specific values instead of having everything loaded into your RAM while your code is executed, right? That's a lot of question, man. It's a lot of question. Maybe you're talking about scope. Okay, but if you're just talking about functions in general, so what a function is just a piece of code that it's reusable code, basically. So if you have a very specific thing that you want to do, so for instance here, I'm going to write a function that's going to calculate pay based on the hours worked and the pay rate. Okay, I might be writing a program that needs to do that lots of times. So when you get to a point in your program where you need to do a particular task and you know you're going to do it a whole bunch of times, that's usually the signal for you to be like, I should write a function to do this. Because I don't want to have to write that logic over and over and over again. I want that all to be encapsulated in one spot. And now that's like the main utility of functions. And they're very important. Functions are like extremely important in any programming language. It's a crucial concept, which is why we're talking about it right now. Doesn't really have much to do with the efficiency or RAM. Not really. I mean, you can, but I mean, from an efficiency standpoint, it actually is more efficient to just put everything in main, or it can be more efficient. But I don't think of functions as something you would do for efficiency. You do it from a memory storage efficiency standpoint. You do it more from a making your code much nicer to use for reusability purposes, for efficiency for writing code. I don't know if that helps. I think that's what you're asking, though. Dang, throwing shade. And scope was hierarchy, right? Oh my. So scope has to do with when a variable is visible. And actually, depending on what you're doing, it's also when something is, so when a variable is visible, so when it is accessible, versus when it is inaccessible. Scope also is used for allocating and deallocating memory. We're going to talk a lot about memory in this class. A whole bunch. Way more than you would have ever done in your previous class, because it's extremely important. This is the class where we start really talking about like how to write things efficiently and and fundamental data structures that sort of make your code, well, it's not make your code, but fundamental data structures that pretty much all of computer science is built on top of. Okay, and so you need to know kind of low level like what's happening. All right, so we're going to talk a lot about that. Right now, this is a little bit of review. Okay, so I'm going to go ahead and write this function now. And I'm going to use this template to kind of guide me there. Okay, so let's think about what this thing's going to do. So I'm going to write a function that basically calculates pay. And the two pieces of information that I'm going to have is hours and pay rate. Those are the two pieces of information you're going to need. And I'm going to make it more sophisticated than this because I want to deal with overtime. So if I was calculating pay, but the end of result of this is I'm going to, take a float and multiply it by a float. And so what am I going to get back? I'm going to get back a float. The pay that's going to be returned from this function is a float, right? That's the kind of data that's going to come back. So therefore, the return type is going to be a float. Okay. Now, so that was this bit. Okay. Now the next thing I'm going to do, function name. All right, here we go. Let's do it. Calculate pay. Okay. So that's just the name I'm going to give this function, calculate pay. This is how, when I want to call the function later, that's how it'll know what I'm talking about. I have to give it a unique name. Okay, then we're going to do open and close parentheses. Okay, this is this part right here. All right, and then inside of those parentheses, I can define a parameter list. The parameter list, there's a little bit more review. Parameter lists are variables that you are declaring. They are scoped locally to the function. Right, so they are just variables. They're local variables. That's all they are. Their only difference between a parameter and a variable that you declared inside the body is how it gets initialized. That is literally the only difference. Okay, so you define parameters usually because you have information that you would like to have passed into the function so that you can use that information to do whatever the function is going to do. In this case, right, there's two pieces of information that are going to be outside of the function. I'm collecting this information out here in main. So here I am in the main function, right? At this point in main, I will have collected the hours worked and the pay rate. This information will be in main. It will not be in calculate pay, which means if I want calculate pay to have access to that, I need to pass it to calculate pay, which means I need to define some parameters. So I'm going to do that. Let's see here. And they're both floats, right? So we'll say, I don't know, what did I call them? Hours worked. And just to be really clear, this is a param. I'm going to give it a different name. Sometimes if I don't do this, people think they're the same thing. They're not. Pay rate param. Okay, so I'm going to do that. Okay, so I'm doing this. I'm putting the word param at the end just to make it perfectly clear. This is an entirely new variable. This variable has basically nothing to do with this variable. They are taking up two completely different spaces in RAM. They they have none the two shall ever meet, right? They are two places. Okay, that's why I'm naming it. I could have named this hours worked, which would have been appropriate, but then I know sometimes people think that this means that this is the same thing as this, and they're not. They're different variables. Um, okay, now we're going to get into the body. Now we got to talk about how in the world does this thing work. Oh, I have something. 2 years of Rust. I'm sorry, you had Rust. I guess I've got studying to do. Yep. Thanks for the refresher. Oh, that's no problem. No problem. Rust is weird though. Rust is weird and it's very efficient. It's a good language. I haven't got to play with it as much as I wanted to though. Like the syntax is cool. It can do a lot of really cool stuff. I haven't had a chance to play. I've been doing other junk. I've been wasting my time. All right, so let's see here. How am I going to calculate pay? Well, obviously, as long as they work less than 40 hours, then this is the standard rate. If you work less than 40 hours, then it really is just hours times the pay rate, right? So let's just say if hours worked is greater than 40, then we're going to do something, figure out overtime, and then we'll return, whatever that is, right? I'm going to put 0 here for now. If that doesn't happen, though, if it's not over 40, then this is a simple calculation. I can literally just do exactly this again. It's just pay rate times, so we'll just say return hours worked times pay rate. Okay. So if it's less than, if this happens, then we'll do something special and we'll return out from there. If that doesn't happen, then we'll just do the normal thing, right? That's all we're going to do. Okay, so let's figure out the more complicated thing now. Let's figure it out. Hey, this is a good opportunity. Let's do it. So, I told you guys I'm going to start showing you some generative AI. I know how to do this, right? But this is one of those opportunities where if you understand what you're trying to do, you understand what you want to happen right now, right? We all know what we want to have happen. We want to write some code that's going to figure out your your pay if you worked more than 40 hours in a week, okay? I would assume that AI could figure that out. It's actually not that complicated, right? So I'm going to go ahead and turn on my good friend Copilot, enable. And let's just see what it figures out, right? I've already wrote some kind of the general outline here. So let's see how smart it is. Let's see what happens when I go down here. What's it going to do? Okay, so what it wants to do is it wants to create a new local variable called overtime hours and set it equal to the number of hours worked minus 40. That makes sense. So all the hours over 40 it wants to capture. Totally makes sense. I agree with you. It's a good idea. Now it wants to figure out what the overtime pay should be. Overtime pay should be the hours, the amount of overtime hours you had, which is what this was, and then you multiply those hours by the pay rate times 1.5, right? So you're getting time and a half for all the overtime hours. Totally makes sense. Now what's it want to do? Let's see. Oh, does it want to do anything else? Are we done? Really? Do I hit enter again? Will it do? Oh, that's beautiful. It wanted me to space it out. That's fantastic. All right. So then we do float regular pay is equal to 40 times the pay rate, right? So for the first 40 hours, that's what regular pay is. Makes sense. And then for the next part, do I have to do this again? Now, when we're done, we're just going to return the overtime pay plus the regular pay rate. I think we're good here. I think that's wonderful. And then we don't need this here anymore. So very good, very good. Thank you, AI. You've done magnificently. I'm going to turn you off again because I don't want that to be the whole thing. So that was an example of where it was fine to use the tool. The tool saved me a little bit of, scratching my head. I just could let it do what it thought made the most sense. And then I just kind of looked at it and was like, yeah, that makes sense. Cool. I believe that that's how this should work. Now, could I have structured that differently? Yeah, I could have. From my perspective, it's a little bit unnecessary for me to be creating all these extra variables. In my opinion, this is a little wasteful because now you're allocating RAM for things that maybe you didn't have to store in RAM per se. So the one I'm actually thinking of specifically is regular pay. right? Regular pay doesn't really need to be there, does it? Like, I could have just said, couldn't I have just like got rid of this and then just said regular pay is actually just this, right? So wouldn't it have been just as fine for me to do something like that? Okay. And then I've removed an unnecessary variable from the equation, right? So the other thing I'm now just trying to demonstrate is that like AI is great and it has a great way of doing certain things, right? But it's not like some sort of magic panacea, and it's not like the always the absolute best way. There's lots of ways you can do it, right? And there might be some situations where what AI thought was a good idea, you might know, well, for my special circumstance, I want to do it a slightly different way. Okay. So, anyways, just point it out there. Like these are things to consider. But it's a very powerful tool, and I'm going to regularly try to do stuff like that. Okay. So I think this should work though. So basically, I wrote my little function. So here's my uh, pay given. There you go. That's what it does. Okay, and emphasis on the word definition. This is just a definition. Not this doesn't actually run any code. That's another little bit of review. When you define a function, you're just telling the the computer, you're telling your program, this is how I would have you do it if I wanted you to do it. It's the blueprints. Doesn't actually do anything all by itself. If I ran this program right now, this would never get called and therefore it would never run. None of this code would ever run. This is only useful when you call it. Okay? So let's go do that. So now down here, let's just swap this out. So I'm not going to do that anymore. Now we're going to get the pay. And so I'm actually, since I'm going to use the pay down here to check something, I'm actually going to put it in a variable. So we'll say, calculated pay is equal to, and then we'll say calculate pay. There we go. And then what does it want? Oh, maybe I should call it something different. I don't know. That's really close. Here's what I'm going to do. I'm just going to call it pay. Okay, there's the pay. Okay, and then we'll say pay is equal to calculate pay. And now we're calling, this is us calling the function. Okay, so here we go. Oh, shoot. Call, or invoke is the other word sometimes used. The calculate pay non-member. Good deal, right? Okay. Now, right away, it's telling you there's a problem. Can anyone tell me what the problem is right now, other than I'm missing a semicolon? VS Code's already saying there's a problem. There's a little red squiggly right there. Why is there a problem? What's wrong with how I'm trying to call that function right now? While you do that, I'm going to read the rest of it. I meant rest as no coding. No coding? Oh, rust as in like you're rusty. Sorry. I hear rust and the programmer in me just goes, oh, another language? That's good. I haven't given any parameters. Well, no, I did get parameters. The parameters are right up here. These are the parameters. Remember, they're part of my parameter list. But you're almost using the right word. What do you have to provide when you call the function that will initialize these parameters? What is that word called? Do you guys remember? Bonus points. Bonus points. Who's got it? There's a relationship between parameters and the other buzzword. Everyone's scratching their head. Nobody knows. It's okay though. It's okay. As David was just mentioning, there's some rust happening here. I'll give it one more second for the lag, but if nobody gets it, it's fine. My wife is going to bring me a Starbucks because she's my hero. I didn't have time to get any this morning. So I'm just here drinking water. Just basic water. What's wrong with me? The word I'm looking for here is argument. Okay? So when you call a function, if that function has parameters defined, okay, then you must provide arguments which will data, which will be used to initialize these variables for the function, right? So this is why I was trying to say this is important thing. This is something that, I mean, when you first do the functions in your 20-year equivalent class, this is usually everyone's head explodes. They have a hard time with it. The relationship between parameter lists and arguments and how they get used. So the important thing to understand here is that these are separate variables. The only difference between here, if I came in here and did this, I don't know, float other thing, right? The only difference between this and this is how they get initialized. That's the only difference. They are scoped exactly the same. They hold the exact same amount of information. They will go out of scope at the exact same time, right? There's no difference between them other than how they get initialized. These variables will get initialized from the arguments that are passed when the function gets called. This is inside the body, so the only way it gets initialized is if I do something inside the body. So if I do something like, 3.14 for like pi, ooh, pi, sounds delicious, right? That's the only way that's getting initialized is if I do it inside the body. I can't initialize it from something outside of the function, right? I can only do it inside. That's the only difference, okay? I know that sometimes trips people up. Maybe it was worth a little refresher there, okay? So because I did define some parameters, let's go ahead and pass some arguments. And what are the arguments in this case? Well, if we go over here, you can see VS Code's even cool in telling you I want you to pass it a float for the hours work param, and then I want you to pass me another argument that's a float for the pay rate. Okay, well, lucky for us, we have both of those information here in main. We have an hours work variable and we have a pay rate variable. So that's what I'm going to pass over here. I'm going to say hours worked and pay rate. I'm passing these. I'm passing the values stored on these local variables in main, and those values are now going to be copied and put into initializing these variables when this function runs, and then it will use those values to do its thing. Yeah. Okay. Got that. Let's run this guy. See what happens. See the magic unfold. Pay. All right. That worked. I got an executable. No errors. Great. So let's run it. Welcome to the pay calculator. How many work? I don't know. 40 hours. Or let's do less than 40 hours because I want to see if the overtime thing works. So we'll do 10 hours at $10 an hour. So what do we think was going to happen here? That's 10, that's 100. You made less than or $100. Wow, I made exactly the cutoff point there. Yeah, I didn't make over 100. That's funny. Here, I'll do it again. Make it less confusing. Here, let's go with 6 and 10. Okay, so you made 60. You made oh, did I not actually print the actual? Oh, I didn't. I used to print it right here, and I'm not doing that anymore. So here's what I'll do instead. I'll copy that. My bad. Should have let the AI write it. It wouldn't have forgot. And we'll just do pay, and then here, instead of doing it that way, I'm going to use pay now. There we go. Okay. There we go. Good deal. I calculated it and then I never used it for anything, like a dummy. There you go. And there. What did I say? 6 and 10. And you make $60. Makes sense. All right, which is less than or equal to 100. Everything works fine. Okay. But now let's run it again. And this time I'm going to say 42 hours. You all know my favorite number, right? You worked 42 hours, which is more than 40. And your pay rate was 10 still. Just make this nice and easy. Okay, so how much did you make now? Okay, well, for the first 40 hours, you should have made $400, right? Because you were making $10 an hour for 40 hours. It's $400. Okay, but then for the 2 hours over that, those 2 hours weren't at $10 an hour. They were at $15 an hour. So that's why you ended up with 430, right? So that works. This looks like this is working pretty well, and that is more than $100. So look at that. Okay, so everything's good so far. From the perspective of a user using this program, everything I just did in here didn't really change anything other than now it actually does overtime, right? But we know, as the programmer, that we have changed the structure of how the program works, right? So this is kind of a this is probably a pretty decent C program now. Pretty decent little C program. All right, and I'm going to get rid of this. I'm going to give you this code, like I said. I'll give you the code. So I want you to get rid of some of the superfluous things here. Any questions? That's nice and dandy. Oh, yes. Okay. Let's take it up a notch again. So this is sort of what I would expect like a C programmer to do. In that C programmers tend to want to write functions. They want to write functions to do things. They want to functionalize their program. As many functions as they can get in there. And the reason they're doing that is for what I was talking about. It makes it more modular. Makes it so you can reuse parts of the code more easy. Okay. But now let's get past 1985. let's do pay 2. Okay, because we're not using, C specifically. We're using C++. Let's be C++y people, right? So let's start talking about. I'm just copying the code over here, so I'm going to give you both. I'll give you pay, and then I'll give you pay 2. Here, maybe I'll change this a different name so it doesn't conflict in Canvas. Pay. Oh, maybe this is pay 2, really. Okay. Oh, now it's going to get all messed up. Okay. This will be pay 3. Because technically pay was the one we did on Tuesday. This is pay 2. Yeah. Let's keep the number order correct, right? Let's be good about this. Okay. So this is what we have so far. This is, like I said, it's a pretty good C program. I would say that we could do more. Okay. Let's do the C++ thing. Let's make this an object-oriented language or object-oriented program. Right? So that's really the big distinction between the C programming language, and C++. C++ is an object-oriented language. I would argue it is the object-oriented language. It is probably the first very commercially successful object-oriented language. It is the reason why people made Java and C#, right? It is the reason why these other languages came out. It's also the dominant paradigm that has existed for decades in industry. And it really is because while functions allow you to be modular, object-oriented languages allow you to be even more modular, and they allow you to reuse code even more so. You can do more with it. That's a more powerful paradigm. So let's do that. You want to see how loops would work? I don't know how I'd even put a loop in here. I guess I could just put a big loop around the whole thing to see if they want to run it multiple times. We could do that. We'll do that at the end. That sounds like a good idea. But for now, at least, let's focus on the object-oriented stuff. And to do that, I'm going to actually take a little journey away from the code, and we're going to take a little journey over to OneNote, and we're going to talk about RAM. And those of you who've had me before in CSCI-20 you've seen this. This is not like this. This is the stuff of your nightmares, I'm sure. So it's not going away. In fact, if anything, it's going to get a more prominent role this semester. So I'm dusting off my little drawing tablet thingy here. Let's talk about how RAM works. Okay, just a little quick review. So RAM, random access memory, is the memory that is what your computer programs use while the program is running. Okay, so I'll scroll down a little here. Gonna do that. Oh boy, that's a little too much. Maybe right here-ish. That's good. So hopefully you remember this. I usually draw it like this. So let's imagine this is your program P, right? It's running. When it needs to store information in variables, when you declare a variable, what you're really doing is you're set aside space in RAM. Your program does not have direct access to RAM, right? There's a middle guy, and that's your operating system. I put them in a little cloud, right? Your program asks the operating system for RAM. It says, hey, I need enough space. So when you get to lines of code in your program like this, and you're like, hey, I need a float. You're declaring a variable, and you're telling it the type. So basically, your program's telling the operating system, I need at least a float's worth of space in RAM, because I'm going to store some information there, right? So your program reaches out to the operating system and says, hey, I need a float. Please give me a float. The operating system's the only thing that knows about where RAM is. It's the only connection to the hardware that you have. Your program doesn't talk to the hardware. Your Your program talks to the operating system. The operating system controls everything, right? The operating system is also doing this for all of the other programs that are running at the same time on your computer. And they're all asking the operating system for stuff. They're all like, gimme, gimme, need RAM, need space, me first, right? And the operating system is like the parent in the room who has to kind of manage all of that. It's a very sophisticated program, has a lot of responsibilities, right? But when your program asks it, it figures it out, and then it goes looking around in RAM for an open spot. It looks for space that isn't being used by any of the other programs, right? And if it finds one, that's what it allocates to your program. So your program is going to say, like, I need a float. The operating system is going to look up in my little wonderfully drawn diagram here. RAM is made up of two components. It's made up of address spaces, which are just numbers, and values. Oh my goodness, what happened there? And values, right? Which is the information that are stored at those specific address locations. It doesn't have this thing called variable. I do that just for clarity. So when I'm drawing things in this little diagram, I can associate the variable that we declared in our program with the address space, the pretend address space that I'm associating it with, right? But really, these two top ones, these two top rows, those are the things that that's what RAM is, okay? So in our little pretend thing, we're going to say that nobody's using address space 100. So the operating system is going to be like, okay, program 1, okay, program P, this one right here, I'm going to give you address space 100. You get address space 100, which means that when this variable gets declared, let's say, maybe you're running overtime hours, right? It's going to associate, oh boy, overtime hours, I can't draw for beans, with address space 100, right? And then what does it do? It's going to put this value that it's the equal sign, what's the assignment operator? It's assigning this value to this location in RAM. So whatever that value is, let's say it's 10. Let's say it's 42, because of course it is, right? That's what gets stored there, right? Address space, value, okay? Different data types take up different amounts of space. That's why they have different data types. Your favorite graphic, right? That's the whole point of this. That's how a computer works. And by the way, this is how every computer works. This isn't like something unique to C++. Every single program you've ever written and ever will write, this is how it works. This is why it's a programming and algorithms class and not a C++ or Go or Rust or whatever class. They're all doing this. In the end, whatever language you're using, in the end, it's just a compiler that's been designed to talk to the operating system in a very specific way so the operating system can actually dole out the space and resources it needs. Okay, enough of that. Let's get back down here. So why am I talking about that? Well, we talked about the primitive data types last time, right? Here they are. I talked about what these are. Hopefully we reviewed them. The primitive data types are the data types you get for free. You don't have to do anything. You don't have to do anything special. The C++ programming language has already been set up such that when it sees the word int, when you're declaring a variable, it knows exactly how much space to ask the operating system for. It does the same thing for float, for bool, and for char. It knows exactly how much space it needs to ask for. Okay? But now let's say we want to create our own data type, our own custom data type. That is sort of the crux of an object-oriented language, is when you're talking about objects, you're really talking about custom data types. Okay? And so, for this program, I'm going to make a new data type. I'm going to come to your top. Now, if you've done any C++, if you've Googled this or whatever, and you inevitably would have heard them say, well, when you're creating a custom data type, you're going to use a thing called a class. That is true. We're not going to do that right now. Why? Because you don't have class yet. You're not classy, right? You're not classy enough for that yet. We will get there. I 100% promise you we will get there. For now, we're going to do it a little easier. We're going to kind of baby step our way that direction. For now, we're going to use a struct, okay? Which is hopefully familiar to most of you. If you took Go, that's the exact same word they use in Go for their custom data types. So we're going to do the same thing in C++. Here we go. I'm going to use the word struct. When you say the word struct, what you're basically telling it is, I'm about to define a custom data type. Now, the custom data type I'm going to make for this little program is I'm going to make a little pay stub. Okay? I'm going to make a pay stub data type. That's what I'm going to do. When you declare a custom data type in C++, here, I'll even do this. pay stuff. Pay stub. Okay. When you do it, you use the word struct for now, right? That's how you denote it. Then you put the name of your data type that you want here. You do an open and close curly brace, and at the end of the curly brace, this is the part that's going to get y'all, you put a semicolon. If you don't put that semicolon right there, it won't compile, and you will spend a lot of time figuring out why. It will be very frustrating for you. You won't like it. Always remember to put your little semicolon at the end of your custom data type definition. If you don't, well, don't say I didn't warn you. All right. Now, inside of this custom data type, I now get to tell the C++ compiler, like, what do I mean when I say pay stub? Just like when it already has set up for an integer, when it says integer, C++ already knows how to tell the operating system how much space to set aside in RAM, right? So I basically need to tell the C++ compiler, when I say pay stub, it wants to know how much space to set aside in RAM. Well, let's think about what a pay stub is going to need. We can look at our calculate pay function for that. When I want to do a pay stub, well, when you see a pay stub, what do you usually see? Well, you see the number of hours you worked, right? You see your pay rate usually, right? You're going to see your actual pay, right? But then you might also see your overtime pay, and you might see your standard pay, or your regular pay, I guess, as the AI wanted to call it, right? Okay. So what I'm going to do is I'm going to make that all of those separate variables inside of my pay stub. They'll all be encapsulated together. So what I'm going to do is I'm going to say there's going to be a float here called hours worked, another float called pay rate, standard pay, and another one called overtime. I'll just do it overtime. Here, do I even need to use the word pay? I'll just say standard. Let's just go with that. Make it easy. And why is it hours works? It should be hours worked. All right, so there. So this is the information I want to hold on my pay stub data type, right? Yes, custom data type, absolutely. And I know it's your favorite graphic, isn't it? It's I'm such a good artist. That's the real reason. It's not the information, it's the manner in which I'm conveying. It's the beauty and the artistic skill that I bring to the OneNote drawing surface. That's what you're here for. That's what the people pay me for. All right, so I can barely say that with a straight face. This is now my definition for a pay stub. What that means is that when I want to create a variable that is of type pay stub, what I have now told the C++ compiler is, when you do that, when you say give me a pay stub object, right, you need to set aside 4 floats worth of space. So let's say I come down here now and I make a pay stub. Let's do it. I'll put it right about here. Pay stub. My pay stub. I'll do that. Okay. Notice how this was the definition again. So here I am. This is a definition. This does not actually allocate any space in RAM, right? This is just telling it how it will allocate that space in RAM. It's a blueprint. Doesn't actually do the work. This is just a blueprint. When I want to actually use the thing, that's what this is. Right? Here's that wonderful word that many of my former students have heard me say before. When you instantiate a data type, right? That's you creating an object. Instantiation is when you're basically saying, go allocate RAM for this data type, for this custom data type. Okay? So that's what I just did here. By creating this variable, I instantiated a pay stub. Right? I create a pay stub object. Object and variable sometimes get they get kind of used synonymously. Technically, there's a little difference. We'll talk about that later. For now, just sort of accept that's what I mean when I say those things. When this line of code runs, it'll be similar to how we were doing it in RAM earlier, right? The difference you can almost think of at this point is that instead of down here in the variable, you can almost think of it as being like, well, when you set up a pay stub, it's not just gonna, like, we're gonna pretend that like a float only goes from 100 to 200, right? It's only like it's 100 like bits or something. Like that's not realistic at all. But like let's pretend, right? Then that would mean that when you make a pay stub, you're actually going to make 4 of them. You're going to set aside 4 of them all at once. This whole thing would be, oh, actually, it'd be more like this. It'd be like my pay stub. All of this whole space, that is my pay stub. And each one of the member variables, so that's what these are. These are member variables, right? They're members because they are part of a custom data type. Just like I said that this was a non-member function because it is not part of a custom data type. It was existing outside of any kind of custom data type. These variables are very much part of a data type. I would never do this, but theoretically you could call all variables that are not inside of a custom data type non-member variables, right? I'm just not going to do that because that's kind of silly. I've never heard of anybody saying that. Usually you just want to distinguish member variables from other kinds of variables. Okay, so there's my member variables. So when I want to initialize all these member variables, right, that's how I will do it. I can use them now off of my paystub object. This is just one instance of my paystub. I could have more than one. I can make multiple paystubs if I want. Your paystub, right? These two are completely different objects. They are the same type, but they are different spots in RAM. If I did this, I would have to actually create a whole new section in RAM for your pay stub. It would all go off this way, right? And it'd have different address locations associated with it. Right? I'm trying to make this distinction because this is going to be important stuff for you guys. It's no different than if I create multiple integers, right? Just like if I was, oh, I don't know, here. This float, I could create a float here and then I could create another float here. They're not the same thing. They hold different values. They are different places in RAM, but they are the same type, right? Same thing here. Same type, different variables, different objects. All right. Beat that horse to death. Now, let's go ahead and initialize some of the member variables of this object. In fact, I'm going to move this up a little bit. I'm actually going to declare it up here. And the reason is because now I don't need to create this local variable for hours worked and this local variable for pay rate. I don't need to do that anymore. Why? Because I already have one variable that can hold both of those. So I don't need to do this, and I don't need to do this anymore, right? Instead, I can just do my pay rate or my pay stub dot and use the dot operator to access member variables. You can use it to access member functionality and variables on that object. And look what shows up in VS Code. All the things. So I'm going to put, when you ask them for the hours they worked, I'm going to put that on the my pay stub object in the hours worked member variable. I'm going to do the same thing here. My pay stub dot pay rate. Right? I got rid of these two variables because I replaced them with one variable. Kind of nice, right? This all can stay the same. You entered here. If I want to display that information back out, it's my pay stub dot hours worked. My pay stub dot pay rate. Again, I can just keep using it the same way, except that now everything is tied to one object. One object to rule them all. Oh, thank you so much. There goes my hero. Caffeine. How I missed you. All right. Now, let's move on a little further, okay? Calculate pay. So now we're going to talk about how I'm going to do this. Oh, let me see here. I find it annoying how VS takes a while for it to clear the red underline signal. All right, well, that's actually a good thing. We're going to talk about that more later, because VS Code and other text editors are great at giving you little hints at something that might be wrong. They are not the authoritative source, though. And I'll show you guys an example of why you should never just blindly trust this. But yes, you're right. It would be nice if it was more responsive. I think it's because of how I have it configured. I don't think it's actually talking to the MinGW libraries like it should be. I think it's using something else, which takes a little while for it to process and other nerdy things, right? So don't worry about it for now. But I agree with you. It would be cool if it was more responsive. Okay, got that. So now we're going to calculate the pay. Now, previously I was doing this with a non-member function, right? That's what I was doing here in pay 2, right? This is the C way of doing it. Well, now we're doing it with an object, right? So really, the question you're going to ask yourself is, this information that calculate pay uses, how does it calculate the pay? What information does it need? Oh, it needs the information of hours worked and pay rate. Well, where is hours worked and pay rate stored? It's stored, all that information is stored exclusively on my pay stub, right? So in that situation, it makes sense for me to know, to like actually go ahead and encapsulate the functionality itself onto the data type. I'm going to change this from being a non-member function into a member function, right? Because all the information I need to do that work lives on the object. So let's just put the functionality on the object too, right? So here's how I'm going to do it. It's going to be really sophisticated and complicated. Here I go. I'm going to copy all this. I'm going to hit Control X. I'm going to cut it out of there. I'm going to scroll up just a little bit, and I'm going to go right here inside the definition of pay stub, and I'm going to hit Control V. Indent that again. And ta-da! I can now stop calling this non-member. It is now a member. Right? So for those of you who had Go, that was hopefully very, very satisfying to watch, because Go does not let you do that. Go has that wacky 1980s style thing of doing member functions where you have to like put it outside the body and do all those, the receiver variables and all that junk. Okay, that's all not happening here. In C++, object-oriented language designed to do exactly this. You can just take the definition, and as long as that definition is within, in fact, here's what I'll do. As long as it's within the scope of your custom data type definition, this is now a member function. It's a member because it is inside the scope of your data type definition. That's all you have to do. Right? Nothing new, nothing else to it, nothing more to it than that. Let's see what we got here. I wish I knew how to work my mom's coffee machine. So what you got to do is you got to get one of those Keurig machines. I'm not doing it right now because we're in sort of the hot times. I don't really want a hot coffee in the morning, but when we get into the cooler months, that thing is a lifesaver. You just put the little cup in there, you push some water in, bam, instant coffee. I love it. I love it. I mean, my metabolism and waistline probably don't love it, but I love it. It's great. Okay, so this is all true still. The actual template that you're going to use for a member function is exactly the same. It still has a return type, function name, parameter list, function body. All of this is exactly the same. The only difference is that I'm doing it inside the definition of the data type now. That's it. Only difference. What's my favorite Starbucks? Are you talking about the location, like which one to go to, or what my favorite drink is? I don't know. There's two different things. The first answer is whichever one is closest to me at the moment that or if it's most convenient to get to. That's usually the dominant feature for that. It's like, oh, how do I get to that one fastest? All right. So I got to move on here. Now let's talk about what this function does. All right, and I'll zoom back in for that. Oh boy, that's probably good. I want you guys to be able to see it. So previously, it still was going to return a float because it's still going to calculate this stuff and return that. I can still just call it calculate pay. That makes sense. But now let's talk about this parameter list. Now, why was I defining parameters before? I was defining them because that was the only way that information could get into the function. But now that it's a member function, that's not true anymore. This is one of the big advantages to member functions. Member functions automatically have access to all of the member variables. You don't have to pass them in. They're part of the same object. They're part of the same data type, right? You don't have to pass them in. this information is readily available, which means I don't need, and since hours worked and pay rate were in there and those are already here, I don't need these parameters anymore. Gone. They're not needed. And here, I can just directly use hours worked member variable. So no longer param, I can just say hours worked, pay rate, hours worked, pay rate, pay rate. There it is. See how nice that was? It just simplified this greatly. All that information that it was going to use to do this calculation lives on the object. It's one of the main reasons why I made it a member function to begin with. Just made that a whole lot easier. My favorite drink. I am a big fan of their strawberry refresher acai. I never remember how it's pronounced. Delicious. It's really good. It has a lot of caffeine, which is one of the main reasons I like it. But by default, they put those nasty like chunks of strawberry in them, and I hate that. I hate it. So every time I order, I have to like specially tell them like, don't do that. Do not make this good drink bad by putting chunks of strawberry in here. I do not want to slurp up chunks of seed and strawberry while I'm drinking my drink. Just leave it out. Don't do it. All right. It's the drink I get there by far the most, and it's a nice pink drink, so it's very colorful, just like me. All right. Now that I have done that, I can come back down here, and obviously this is going to be problematic now, right? It doesn't like that, and the reason is because I just got rid of the non-member function calculate pay. So there is no just regular non-member function called calculate pay, so this whole thing is poo-poo, right? So let's fix that up. Now we're going to call or invoke the member function, and just like a member variable, you can invoke member functions off of the specific object that you have. So the one object I have is my pay stub. So I'm going to come on down here. I'm going to say my pay stub dot. The dot operator lets me access the things inside, all the members for that data type. So here's all my member variables, and at the top now, look what I got. There's calculate pay. And because it's a member function now, I don't need to pass it any arguments. It already has that information, right? When we collected that information, I already put it on the object. I just mapped that directly in. Hours worked is already there. Pay rate's already there. Pay rate, this my pay stub already has that information. So now all I have to do is tell it, okay, just use that information, go calculate the pay. Go do it. Calculate pay has now happened, and it should return to me the pay rate. Right, it should return it, and that's what I'm expecting it to do. One thing I am going to do now, though, I am going to come back up here. I forgot about this. I'm going to change this a little bit. One of the other pieces of information I wanted to hold here was the standard pay and the overtime pay, right? That actually is information that I stored here. So remember this? When I was the way AI wanted to do it, I factored this out last time, but now it actually kind of makes sense, right? So the overtime pay was this. So instead of this being a local variable, what if I just tell it, oh, we'll just calculate that and just put it there, into the member variable called overtime. And what if I, instead of doing this, what did I call it? I called it standard. I went against the grain here. That's standard, right? Oh, I left that that way? Oh, that's dumb. Pay rate, okay. And now we can take overtime plus, and then since I already calculated this anyway, I'll go back to what the AI wanted to do before. Boom. And there we go. Now we're good. And when I run calculate pay, it now will automatically, as a part of doing this, not only will it calculate the overall pay, it'll also calculate and store the standard pay and the overtime pay. All of that will now happen as a part of doing this function. It will have updated these member variables as a part of doing that function. So now when I come down here, I can still do pay equals, right? Which is basically what I was doing up here, except now it's just doing it through the member function. Your pay is pay. If the pay is greater than 100, you made more than that. If it's less than that, you get that. Okay? Everything else here should be exactly the same. Let's go make sure that that's true. Pay 3. What do we want to do? Let's go with, what did I do last time? I did like 6 and $10 an hour. $10 an hour. Still $60. That's still less than 100, right? Works the same. How about 42 hours, right? At $10 an hour. And what do we get? 430, which is more than 100. Wait. Still works exactly the same. Everything looks the same from the end user's perspective, but we just dramatically changed how this program is structured. This is a now far more object-oriented program because we introduced this custom data type. This custom data type can then be reused. If I wanted to have multiple pay stubs for multiple people, we could do that now. I could just create a new pay stub. It's just like I was showing you before. I could just keep making pay stubs, right? I don't have to keep making tons and tons of variables for every single one. I can just keep making one variable that represents 4 different floats, right? That's the power of object-oriented design. I focus pretty heavily on it in my 20 class, and that tradition will continue in this class. In this class, it's sort of a necessity, though, because we're going to be building fundamental data structures, and those are all custom data types. That's what they are. They're just fairly sophisticated ones. Okay, any questions about anything I've just done? All right. I will give you this code, of course. If I want to, one last thing I'll do is, since I did figure out the standard pay and the overtime pay, why don't we go ahead and just do that? So we'll say your pay is this. Maybe I'll put it beforehand. Maybe I'll say overall pay, and we'll say pay stub, or my pay stub dot standard your overtime pay is let's see here, overtime. And I just noticed I did something that's going to be a problem here. So I'm going to fix that really quick. And everything else here looks good. One thing I did notice that's going to be a problem. So if they didn't work any overtime, this will never get set and this will never get set. You noticing that? And remember I was telling you in C++, if you don't initialize your variable, then undefined behavior, no idea what's going to show up there. So if I run this right now and I put values in there that don't have this if statement run, these values will never get set, and it's who knows what's going to display there. So actually, there's a good example of what to look out for. This is why this is so important. So I'm going to pick small numbers again, and then look, standard pay 0, overtime pay 0, overall pay 6. So this one, it actually looked okay. It's 0. That's what it did in MinGW, because that's where I'm running this right now. I'm running it on Windows. Let's see what happens when I run it in Linux. I wonder if it'll do the same thing. I'm not 100% sure if it will. It's undefined behavior. Let's find out. It might still be 0. Let's go over to Ubuntu. Pay 3. Okay, now, and just because I don't think I've done it in this class yet, so I'm running on an Ubuntu a Linux shell, right? So this is in Bash on an Ubuntu OS. I run that. So notice when you do that, you don't get a.exe anymore. Now I got an a.out. This is what, if you're on a Mac, this is what I would expect your output to look like, is a.out. Right? And let's run it. And I'll do the same thing, 6 and 10. Oh, look, now it's -0. Whoops, that's not a thing, right? So this is my point. Initializing your variables in C++ is a big deal. Like there's no way to know what it's going to do if you don't initialize it. It's dependent upon the operating system and the version of the compiler you're using, and it becomes a big problem. So the easiest way to fix this would be to do this. Since I'm always going to be calling calculate pay no matter what, I would just say, let's just initialize overtime pay, overtime to 0, standard to 0, all right? And then the other two, hours worked and pay rate, I already know down from my logic that those are always going to be set, so we're good. So this will assure that these always start out at least at a consistent number. And now when I run it, 6, 10. Now I don't you'll get -0. I don't even know how you would do that, right? And that'll be the same over in Windows or anywhere else I run it, right? These are the little gotchas of C++. Any questions about anything I've done? I will give you this code, so don't sweat it if you're like, how did he do the thing? I'm scared. What happened? I'm gonna check my notes. That was all a bunch of review. Hopefully nothing new. Conceptually, I'm hoping that was all just review. Like that nothing I did there was new for anybody. It was just really the syntax should have been new. One of the things that you probably got sad when you saw me writing this this right here. Remember when I was talking about the primitive data types? I'm assuming that some of you got really sad when I did this because you saw these primitive data types and you saw that something that you were expecting was missing. There's a missing data type. You know what it is? There's no string here, right? Char is not a string. This is one character. Right? That's it. Not many characters, one character. Right? A string can hold lots of characters. Right? There is no string primitive data type in C++. Okay, so let's go do this. Let's go strings.cpp. Let's talk about that. So what that basically means is if I remove these guys and I do int x, okay, this program will work. Literally, I don't even need these to have this work. Right? Compiles just fine. No problem, okay? Because these are primitive. That's what I meant, is that the C++ compiler doesn't need anything extra. It knows exactly how much space to allocate for an integer. But if I come in here and do this now, s, immediately VS Code's telling you that's going to be a problem. All right, but you shouldn't trust VS Code. Just do it. So here you go. Immediately, it's like, I don't know what that is. I don't know what a string is. Okay, that's because it's not a primitive data type. You have to have something to define it. It's a custom data type. It's just like what we did here with the pay stub. You have to custom build it if you want a string. Well, lucky for you, these boilerplate things I have you put at the top, this is a library. When you import this library, when you include it, right, it's actually not including directly the implementation for string, but it's including another library that is. So when you include these two things, when you include this library and add this namespace, you get string for free. By just putting those back into this thing, now it compiles just fine. Okay? But I'm just trying to make a point here saying that this is not a primitive data type. It's a custom data type. Somebody else built it. This is also the power of object-oriented programming, right? Is that you don't actually have to know how string works, really. I mean, you should, but you don't really. You just know, well, I just include this library, and then I get this really, really sophisticated data type that lets me do lots of neat stuff. And this is why object-oriented programming allows people to share code, because you can just package things up into libraries and give them to other people, and then they just include them, and then they can use them for whatever they want, versus having everything like all in one big file that you have to like manage. Okay, that's why they do it that way. It's a lot easier. Okay, so let's talk about string. So I'm going to do this. I'm going to try to do this quickly. We're going to write a little program that lets me collect some information. So I already talked about char. Okay, so if I have a char, and then I ask them to enter their name, and then I do cin char or cnc, right? Okay, and then I say Okay, so this is what's going to happen. I'm just collecting a character. Okay, so I just want to prove to you what will happen here. Oh. Okay, enter your name, Matt Mast, right? But look what happened. Only the first character was captured. That's why you can't use char for this kind of stuff, right? This only has enough space to hold one character. It can't hold a string. It can't hold a whole bunch of stuff. So when I typed in all that stuff into the input buffer, it mapped the first character to the one place in RAM, the amount of space I had in RAM to hold it, and everything else just kind of got lopped off. All right. So let's replace that now. And I'll put, I don't know, name. And we'll go down here. We'll say name. We'll come down here. Right. And if you do this, so let's do this now, and you can see the magic unfold. Matt. Okay. So you do have a string object. It's part of it's part of the string library, and it's great. It lets you hold things. So don't get too sad that it's not a primitive data type. There is a very readily available data type, and strings are like an incredibly essential data type for any programming language. Like, they all need it. Some languages allow it to be just a primitive, like in Go it is, but older languages that wasn't the case. You would have to build it yourself. And in the C programming language, which is not object oriented, the way you would do it is you actually had to use what was called a C style string. We'll talk about that probably next time. But in this case, I just want to introduce string. There are some things about strings in C++ that all beginning C++ programmers hate. They learn to hate it. It's one of the things that makes people dislike the language early on. So if you're like a brand new C++ student, you'll run into one of these things and you'll be like, this is the dumbest language that ever existed. And you're not wrong. It's annoying and frustrating. So we're going to talk about that in very short amount of time so that you can get past that. Okay? So here we go. I was able to capture my name, but now let's get a little bit more formal, shall we? Let's go ahead and enter your full name. Okay? So that's all I did. I'm just, instead of saying, oh, enter your name, I'm going to have them enter my full name. Sounds good. Let's do it. Matt Cervantes. Uh-oh. What happened to my last name? It's gone. Now, don't tell me that one of you wouldn't have done that. You wouldn't have been like, well, he showed us how to do this, and you use the CN object, and you push the thing in, and the strings are really great. And then you would have done this, and this is what would happen, and then you'd be like, why the heck did that happen? So anyone have a thought? Why did that just happen? I don't have a lot of time, but this is actually one of my favorite parts of this, is just trying to guess what could possibly be wrong. What could be wrong? Everyone's scratching their head. I don't know. The language sucks? That's why. Although I haven't got a lot of that. Most people are pretty excited to learn C++, right up until I do this lecture, the second lecture. And then they're all, I don't know. The space is not a character. Is it not a character? Let's test that theory. Let's test it. You have a theory? You should test it. It's a good idea. How about I do this? There, I just put a space in it. I put a space there, right? This is clearly a space right here, right? Okay. And then I'll do that first. So first thing it's going to do is try to print out what I initialize it with, and then it's going to do this. Let's find out. Hello world came out there. Didn't come out there. Dun, dun, dun. It was a good guess, though. You're on the right track. It clearly has something to do with that space, right? Something is wrong with the space. Something is wrong. It worked. Uh-oh. I don't know what HHU means, but I think you're right. I think you're probably kind of going like, huh? I think that's what you were going for. Okay, so it kind of worked. So clearly strings can have a space in them, right? They can have a space, but for some reason when I did it here, it didn't work. It didn't like that. Okay, so here's what we're going to do. I'm going to take a little journey over to OneNote so we can draw some more. I know you guys love it when I draw. Banana Jewel said it was her favorite part of the day, right? So here we go. We're going to talk about some stuff. Okay. We're going to talk about the input buffer. Now, if you took CSCI 20 with me, we talk about this pretty much in depth. I've noticed that not everybody does this, so welcome to CSCI 21 with Matt. You get to learn this now. This is a pretty important topic, so I definitely want people to be aware of it, okay? So, the input buffer. Remember when I talked about, when I was just a minute ago and I was talking about this, and I was saying how your program is always talking to the operating system. The operating system is the only thing that like really can do anything with hardware. Or believe it or not, input is hardware. When you type something on your keyboard, that's coming from a piece of hardware. Your keyboard's a piece of hardware attached to your computer, right? Okay. So really that information that you're typing in here doesn't go straight to your program. It goes to the operating system first. And the operating system sets aside some space to hold that information, and we commonly refer to that space as the input buffer. The input buffer is basically just a big block of RAM, okay, that's set aside specifically for capturing input. There's actually a lot of input buffers, but the one that we talk about in this class and most programming classes is called standard in. Okay, so standard in is sort of it's the standard input buffer. It's the one that you use pretty much all the time, and it's especially the one that's attached to your keyboard from your operating system, okay? When you type something, it goes in here. Now, I made a little chain here to represent each of the characters. They're all stored as separate characters, just like they did in C, right? So when I typed it in, right here, I'm going to run this again, and we're going to do it slightly differently. I'm not going to use my full name because my name's long, so we're going to do it again. And this time, I'm going to say my name is Bob C. Okay? But I only got Bob here, right? That's kind of weird, right? Okay, so let's say I did that again. So this is what happened. Okay? When you got to, here's what I'm going to do. I'm going to get rid of this because that's unnecessary now. Oh, except I do need the string still. Here's what I'll do. Like that. Okay? When it got to here's where it allocated the space. Here's where it printed that thing to the terminal. And then at this point, right here, cin. Remember we talked about this last time. What is this? This is an object. In C++, cin is an object. It represents the input buffer. It is an object. It's an abstraction that literally represents this. Okay? So when you think of cin, you should be thinking of this whole thing I'm talking about. Okay? So right now, when you first run your program, right, there's nothing in here. The input buffer is blank. I haven't typed anything yet. So when it gets to this line of code, what's happening? It looks at the input buffer and it tries to extract. That's what this is. Remember, this is the extraction operator. This is an operator that works on this object. It tries to take the information out of the input buffer and move it into this variable, into the RAM location that this variable represents. Except that for right now, there's nothing in the buffer. That's why the program pauses. That's why when you get to that point in the program, since there's nothing in the buffer, the program pauses and it waits. It waits for you to fill the buffer with something, right? So when I type Bob C, right, and then when I hit enter, that's its way. That's the operating system's way of saying, here's the data. So I pass the data in when I hit enter, right? And what happens? We get Bob space C. Okay? Now the information is in the input buffer, okay? And now we'll have this data, okay? But then let's talk about what it does next. This operator will now operate on this object. What does the extraction operator do? It's an operator. This is an operator. Just like you're probably more used to seeing operators like this, where like this is an operand, this is an operand, and this is an operator. It operates on these things, right? So you're used to seeing things like plus, times, divide, minus. Those are all operators. You're used to it like in a math context. This is also an operator. It's operating on this thing, right? So when you consider it that way, it's important to understand what that operator does. It does a very specific thing, just like the plus operator does a very specific thing. What that extraction operator does is it starts at the very beginning of your input buffer, and it scans until it hits one of two things. If it hits a new line, actually, that's the one thing I forgot to put in here, enter. The enter key was pressed, which is kind of like a new line, right? When you hit enter on your keyboard, that's like when you're in a word processor and you hit enter, that's like a new line usually starts. That's a key press. It actually gets put into the buffer. So all of this is sitting in the buffer, okay? When you use the extraction operator, it is going to start here and it's going to keep scanning until it hits either a space or a new line. Well, guess what it first hit? Space. And then it stops right here. And all of this is what it grabs. And it puts all of that into whatever the variable is. That's why the first time I ran it, when I typed Matt, there was no spaces in Matt and everything was fine. There's no spaces in Bob, everything's fine. But the second I put a space in there, it stopped. Okay? And then it just brought it back in. Funnily enough, all of this now is still in the input buffer. So if I come back over here now, and let's say I do this, cin name again, cout remainder, okay? Watch what will happen now. So here's the first cin object. So the first time I did it, and I'll run it again. Bob C. Look what I did. Your name is Bob, right? So that was where we got to here, and I actually had to type something because the input buffer was empty at this point, so I had to type something. But then, after I hit enter, what happened? I hit enter. This operator ran and got all of this data up to this point. Then we did cin again, right? And at this point, we are still operating, the cin object is still the input buffer. This is still an operator, the extraction operator, but it's going to pick up from right here. Except now, all this stuff is still in there, right? So it didn't need to stop the program. It just grabbed whatever was left in there, which is exactly why I didn't get prompted again to stop. It just said, okay, cool, read the rest of it in, put it into name, and then spit out name. And that's why I got C at the end. Okay? That's why that works. That's how the extraction operator works. Understanding what's actually happening under the hood is kind of paramount to understanding how any programming language works. Right? So that's what's going on here. So now you might be going to yourself like, okay, that's interesting, I guess, but how would I actually capture a string that kept everything, like the string with spaces in it? Sometimes I want to capture like a full name and I want to have spaces in it. How in the world would I do that? This seems like this would be annoying. And you're right. So the good people at whatever library, I think it was in the strings library, they knew that that was the case, so they built a special function for you. Okay. So if you don't want to deal with that, let's say you actually wanted to capture somebody's full name. Okay. Well, in that case, instead of using the extraction operator, which works in a very specific way, you can use a different thing that will operate on the input buffer in a different way. And now we're not talking about an operator anymore. We're actually going to call a function. That function is called getline. Getline is a special function that will get an entire line from an input buffer. Right? The first thing that you have to pass to the getline function is the input buffer. Well, what's our input buffer? Well, that's the cin object. So the first thing you have to tell it is, this is the buffer I want you to read. The second thing you have to give it is the variable that you would like to read all of the information into. In this case, that would be name. When you call this function, right, and you pass it those parameters, it will do the following. Bob C, and now I get Bob C. Okay. The difference here is that getline doesn't work exactly the same way as the extraction operator. Getline, when it runs, and I guess I should get rid of all of this now. Boop, boop, boop. Okay. So when you call getline, you pass it the cin object and a variable, it will look into the input buffer, just like the extraction operator did, except that what it does is it scans all the way up to it finds a new line. It will include space. It doesn't stop at spaces. So in this case, it would have went all the way up to here, and it would stop right here. Okay? And all of this is the data that it would collect, and it would map all of that into this variable. Okay? That's why that worked. So now you're happy, you figured it out, the problem is solved, happy day, right? Okay, so I'm just trying to showcase this is how you're able to collect the information. Now here's also an opportunity, very quickly I'm going to mention this because we were just talking about the red squiggly lines, right? You might be looking at yourself and be like, hey, you know, VS Code's still complaining about that red squiggle line there. Why is that red squiggle line there? Well, obviously, it still works, right? I just compiled this, red squiggle line and all. Still compiles just fine. So this is a good moment for me to mention, you should not always trust VS Code. You should not always trust your text editor when it tells you something is wrong. The text editor is not the authoritative source for whether or not your program has a compilation error. It's at best, it is a educated guess. It's usually a pretty good guess, but it's a guess. The only thing that actually knows whether or not your program has valid, syntactically correct code is the compiler. Full stop. All right? That is it. So if you want to know if something works, you run the compiler, and the compiler is the thing that I'm doing right now. G++ is our compiler. All right? You pass it there, and if it says it's fine, then it's fine. VS Code is doing its best to guess at something, but that's it. Right? If you want to know why it's complaining right now, is though even though VS Code's text editor is pretty smart, sometimes it gets it wrong. Right now, it's getting tripped up because it doesn't realize what it's thinking is getline is not defined in this library, and it's right. It's not defined in that library. It's actually defined in the strings library. What it's too stupid to realize is that strings is included in the IOStream library, and so it thinks there's a problem, but there isn't a problem. If I wanted to make VS Code happy, all I'd have to do is come up here and do this. And now it's going to think everything's fine. Okay? But it's not because... Oh, now is it whining about that? Is it just string? I don't know. Maybe it's just string. Yeah, it's string. Now it's happy. It thinks that this is fine. But this is unnecessary. This is redundant code. I don't like putting redundant code in my programs. So I'm not going to do that. And we're all just going to deal with VS Code being stupid. Okay? Just a little moment to let you know, don't trust the red squiggle lines as some sort of authoritative, always correct thing. It's not always correct. Sometimes it's wrong. Always compile your code. Always. All right. Next thing I'm going to do, let's add a little bit more to this program. Let's do an integer, and we're going to have it also collect my favorite integer. Okay? Now, oops, my favorite integer, come on. When you're collecting something other than a string, you have to use the extraction operator. Well, you don't have to, but you will always use the extraction operator. It's like the most common and obvious thing to use. It's not like you can put spaces into a number anyway, so, right? So, in this case, I'm going to use cin with the extraction operator, and I'm going to say favint, okay? Because I'm collecting an integer, I want to use this operator because it's the most obvious choice here, right? That's what I'm going to do. And then after that, I'm going to say, in fact, I'm going to put this up here, right? I'm going to say your favorite name. Your name is that. See out. Your favorite integer is favint. Okay. Let's run it and see what happens. Let's do it. I'll do my name again. What's my favorite number? You all know my favorite number. It's 42. It's the answer to the life and everything, right? Everything works just fine. So you can mix and match, right? You can use getline when you want to retrieve information that has spaces in it. As long as it's a string and you want to capture the string with all of its spaces, you can use getline. When you want to just collect like any other information, which probably is always going to be like a float or an int, a bool, I guess you could, maybe just a single character, you could just do that. You could use the extraction operator and that's fine, okay? You can mix and match. But with the last couple minutes I'm going to do, I'm going to change this program just a little bit, and I'm going to change it to represent something that's more true to me and my identity, right? Because if you want to get to know me, what you really need to understand is my favorite number. That's the most important piece of information. My name is almost secondary to that. So I'm just going to take this, I'm going to hit Control X, and I'm going to put that on top. I'm going to put it here. Okay? So that's it. That's the only thing I changed. Okay? Now it will ask for my favorite number first, then it will ask for my name, and then at the end it'll print them both out again. Okay? The only thing I changed was that. Compile. Compile is just fine. Run it. Now it's asking for my favorite number, 42, obviously. Uh-oh. I don't have a name anymore. Why didn't it ask for my name? Stupid C++. Stupid. This is the stuff that beginning C++ students hate about C++. This is this kind of junk. Because it's written in a very specific way. Unless you know how that way is, it can seem like this language is just messing with you. Okay. Anyone want to take a guess? I only have a few minutes. Anyone want to take a guess as to why it just did that? Why did it not let me type in my name? When I had it the other way, it was fine. Remember when I moved it down here? Here, look. I'll leave it in here. Matt Cervantes. And I get to type in 42. Both of those were happy. But when I flip it around, all of a sudden, I don't get to type my name anymore. No idea. Yep. So again, it has to do with understanding how these functions and operators work. Okay. So let's do this really quick. I only have a few more minutes. So let's go here. Let's clear this up a little. Okay. And we're going to go with Bob again. Okay. So let's fix this up to make it look like what we got going on. Oh, Alexa, having a thing there. Okay, so we got cin num. I'll just say num, and then we'll still var for name. Okay. So what happened first? Well, the first thing that happened, and actually I gotta clear out this too, right? So when you did it this way, what was the first thing I typed in? I typed in a 42, and then oops, I didn't mean to do that. I took a 42, right? And then I clicked enter, right? That's how I typed in first. So when it gets to this line, when it gets to cin, right, what does it do? what does it do? Right? There's nothing in the input buffer, right? Or it got to the input buffer. There was nothing there, so it stopped. It prompted. It allowed me to type 42 and then hit enter, right? And then the extraction operator did what? It went from here to here, and it stopped right there. And all of this information was read into that variable. Okay? Exactly what we said would happen. But then what happened? The very next thing it did was it declared some spot for a name. It spit that information to the terminal like prompting, and then getline was run. And what does getline do? Well, remember what I told you what getline does. Getline will read up until it hits the first enter, the first new line. Okay? So where did we leave off? We left off right here. But what's still in the input buffer? It got to right there, and it said, oh, we're done. And it just moved on. There was an enter there still. It hit the new line. It was sitting there waiting for it. I'm done. Moving on. That's not what I wanted to have happen. Right? So understanding what getline does, it's very specific. I know sometimes people think I'm really pedantic because in my auto grader I make you do things like make sure that your output is exactly what it's supposed to be. I'm not doing that necessarily to be a jerk. I'm doing that because that's what computer science is like. It's about being really precise and understanding exactly what the program is doing. And if you don't know exactly what the program is really doing, then you're going to mess things up and it's not going to work the way you think it should. Okay? We need a way to get around this, right? So the problem, now that we understand the problem, now the trick is figuring out how to fix the problem. We know that the extraction operator, when it runs and it reads information, it will stop right before that enter key, and that enter key will still be sitting in the input buffer. So we need a way to get rid of this or get around this before we call getline. Well, thankfully, the last few minutes I have, I will show you the trick. The trick in C++ is a special function. Well, is to recognize that cin is an object, right? Remember I said this is an object. This is an operator that works on the object. This is a function that works on that object. And now I'm going to show you the operator that you're all accustomed for objects, cin dot. If you use the dot operator on cin, you will see all of the member functions, if you're in VS Code, that are associated with it, and all the member variables. There's a lot. It's a very sophisticated object. This is all member functionality and member variables. Okay? And there is one in here that you're going to want to use, and it's called ignore. Okay? The ignore member function will do the following. It will ignore one character in the input buffer. So, if you put the ignore right here between, you spell it right and everything, between when you use the extraction operator and when you use getline, then when it gets to here, like it did last time, and then you call cin.ignore, it will move exactly one character over, and it will put the next reading of the input buffer here instead. And then when you call getline, getline will start here and it will look ahead and be like there's nothing here. So it's time to stop and let the user enter some information. So that's all I did. I put cin.ignore in between the cin with the extraction operator and the getline. As long as I put it right there, hit save, compile, run, 42, enter. Now I get to enter my name. And everything is cool. Okay? So, a little lesson for you here. If you are in a situation in C++ where you are collecting information both using the extraction operator and using getline, if you are in a situation where you are using the extraction operator first, and then the very next time that you're going to collect input is using getline, you need to put a cin.ignore in between them. If you don't, that thing that just happened to me will happen to you, and you will spend a lot of time pulling your hair out and hating life and cursing the C++ gods. Okay? I also use this as a brief moment to talk about understanding kind of your role as a programmer. And this is actually, I think it's more to do with human nature than it does anything else. It is often the case that when people, are trying to do something using a tool, and then the tool doesn't do what they think the tool should do, there's a common instinct to be like, the tool is broken. This tool doesn't work right. I used it to do the thing the way I thought that the thing should work, and it didn't work that way, and therefore the thing is wrong. And in you as a programmer, as a person who's entering into like a technology field, you kind of need to get out of that mindset. I'm not saying it's impossible that the tool is broken. It is entirely possible. But you shouldn't be saying that until you have done a thorough investigation of how that tool is supposed to work. There is nothing wrong with the extraction operator. It works exactly the way it's designed to work. There is nothing wrong with getline. It works exactly the way it's supposed to work. But if you don't know how these things work, then you're probably going to use them wrong. And it's not the technology's fault. It's not the technology's responsibility to change so that you understand it better. It is your responsibility to understand how the technology works. It is your responsibility to learn how the tool is supposed to be used and then use it correctly, right? And it's sort of maybe a general life lesson, but there's a lot of things like that in programming where you'll start to do something, you'll think it should work one way, it doesn't work that way, and you might just being like, this is stupid, right? I would say that's an opportunity for you to then start Googling, ask a question, ask a colleague, ask your teacher, figure out, ask ChatGPT, figure out some way to educate yourself on how it's supposed to work. Because I promise you, especially asking yourself if this is a mainstream thing. C++ has been around for decades. This setup has been around for decades. If you know that, it's unlikely that you are the first person who's run into this problem. It's probably that you just don't understand how it's supposed to work. All right, that's what I have for today. So the big takeaway for you here was, if you're in this situation, you always want to call C and ignore after this. If it's the other way around, like it was before, you're fine. You don't need C and ignore, right? Because the extraction operator, it will actually ignore leading spaces and leading new line characters when it's parsing the input buffer. It is only in the very esoteric situation that you are using the extraction operator and then you're calling the getline that you're going to need to put this in between. Only in that circumstance. If you don't and you just start putting ignores everywhere, well, then you're going to start ignoring actual characters that you wanted to read. And then you're going to start getting things like enter your name, and you're going to get Matt Ervantes because it will have skipped the C. All right? So just be aware of it. All right. I know I'm over time. Let's head over to this week's homework. You need to have this done. Okay? All right. So you have the weekend to work on this. This is related to the stuff I just went over today. Again, I didn't really introduce any new concepts today. I expect you to already know what an input buffer was. I expect you to know how to, read information, right? But there was a whole bunch of little C++-y things, the syntax of this language, that I needed you to know. So we spent some time on it today. Cubic objects. The point of this assignment is really just, again, for you to get comfortable demonstrating that you know how to build a custom data type in C++. Right? If you took CSCI-20 with me, I have pretty much this exact same assignment in Go when I first introduced a custom data type. Again, it's just meant to get you kind of going that direction, getting comfy with the language. Comic book collection is designed to give you an opportunity to explore what I just did here. I have concocted a program, an assignment, that forces this situation to happen, where you will use the extraction operator and then you will use getline, and if you don't have ignore in there, it will not work. All right? So that's all this is. This is really just an opportunity for you to kind of explore that. I also showcase how to clear the CLI text, and I don't think I actually, maybe I didn't even give you the example code that does that. Did I? Oh, I gave you proper code layout. Oh shoot, there's one more example code that I need to prop here, and it's how to do CLI text. So I'll do that. I gave you some code that will let you clear the CLI. It doesn't work perfectly. I've noticed it works mostly in. It'll work on Windows, and I think it'll work in Bash, but I don't know if it works in all CLIs and all shells. It's it's just there, and it's something you're going to need to know for our first project. So it's just like an opportunity to kind of mess with it. Let me see here, but yeah, that's that. So when it says clear CLI text, you're going to see some an example. Oh yeah, clear the CLI text. Yeah, I haven't published this yet. Haha, sorry. I will publish that here in just a minute. Uh, oh yeah, last thing, and I won't do this. I don't have time for it. Just know this because you'll get Bing for it on AutoGrader. Always end your programs with a new line character. Always. I'll talk about it next time. I meant to do it today, but I forgot. Always end your programs with a new line character. The last the last C out of your program better have a new line on it, or otherwise AutoGrader is going to be sad at you. And I have a very specific reason why I enforce that. Right? It has to do with courtesy and being a good programmer. But if you don't understand that, or you're not assuming that that's what you need to do, then that could be frustrating. So just know that that's a requirement. It's a requirement for every program I have. Any last minute questions? I know I'm a few minutes over. Sorry. It's just the way it goes. It's just the way it goes. Is anyone even on anymore? Y'all got done with it. You're like, are we still talking about this? You're all good sports. Just making sure I didn't miss anything else. I think I got everything else. Okay, not seeing anything, so I think we're good. Have a wonderful rest of your week, your first week back in school, and a good weekend. And be sure to use Piazza if you have any questions about anything. I'm sure that I and others will be willing to help you out. I strongly encourage you to jump on this work as soon as possible. Do not wait until Tuesday to try starting it. Your life will be unpleasant if you do. All right. Thank you, Banana Jewel, for the E. I'll see you on Thursday next week. Until then, adios.